Very good. So the last topic for two populations that we're going to discuss is the difference when it comes to the proportions. Two sample z-test for the difference. A two-sample z-test is used to test the difference between two population proportions, P1 and P2. Of course, when you have the following conditions. First of all, the samples that you're taking from populations are random. The samples are independent from each other. 3, the quantities N1 times P bar. The definition of P bar is denoted here. So the very first sample size times P bar and the very first sample size Q bar. Q bar is 1 minus P bar. N2 times P bar, N2 is the second sample size, times P bar, and N2 times Q bar are at least 5. Guys, if you open different statistics books, other than 5, you might see 10. Some statistic books use 10 as the minimum value. But using our book, we're going to stick to 5. Well, when it comes to difference between two proportions, the test statistic is going to be P1 hat, the first sample proportion, minus P2 hat, the second sample proportion. So again, since we are dealing with proportions, population proportions, the test statistic is related to sample proportions. P1 hat minus P2 hat. Well, the standardized test statistic that we are working is Z, which is equal to, on the numerator, you have P1 hat minus P2 hat minus P1 minus P2. On the denominator, the standard error is P bar times Q bar, parentheses, 1 over N1 plus 1 over N2. After finding your standardized test statistic, you can use either the rejection region or the preferred method, p-value, to compare your P and alpha. So the standardized test statistic, Z. Okay, remember that. Then we have Z. Then to find the p-value, the probability value, we're going to use, well, here you have your Z, and you're going to find the area. So you're going to use your calculator, normal CDF. Depending on if you have a left-tailed, right-tailed, or two-tailed graph, you're going to use your calculator and find that area. To everybody.
Very good. What are the steps that we're going to take? First, we're going to check to see if the samples are random and they are independent from each other. Find the weighted estimate of P1 and P2, which is denoted by P bar. You're going to take the successes in the first sample. In the second sample, add them together and divide it by the sample sizes. You're going to add those together. We call it the weighted estimate of P1 and P2. Check to see N1 P bar, N1 Q bar, N2 P bar, and N2 Q bar are at least 5. Identify your null and alternative hypothesis. What is the level of significance? If you're using the rejection region, you can find the critical value using your level of significance, or just directly use your standardized test statistic Z and find the p-value. Okay, let's go over one example together to feel comfortable about what's going on when we are dealing with the difference between proportions. A study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants in pickup trucks show that 86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seat belts. Okay, so we have the proportion for the first sample and the proportion for the second sample. At 10% level of significance, can you reject the claim the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? Guys, take a look at this. We have percentages and we are dealing with the proportions. So we need to check each step and form our standardized test statistic and then get information about our p-value and compare it with our alpha. So let's take a look at our board and start each step one by one. Okay, perfect. This is our example. In the very first step, assuming all of those requirements are met, in step one, we're going to identify the null and alternative hypothesis. So, what is the keyword? Let's take a look at our example here. It says, a study shows that. So I'm just ignoring this sentence here. A study shows that 86% and 74% wear seat belts. Okay. Exactly 86%, 74%. The claim says, guys, keyword. This is your claim. The proportion is the same. So the claim says the proportion is the same. Claim says the proportion is the same. Keyword. Keyword. The proportion is the same. It means that we have our null hypothesis. Null hypothesis says P1 is equal to P2. And since it's our claim, let's put a little C next to it to identify our claim easily. Our claim and null are the same thing. Alternative hypothesis, P1 is different from P2. Okay, since our alternative hypothesis says they are not equal to each other, it means that you're dealing with a two-tailed graph. One tail on the left, one tail on the right. There we go. A half of the p-value is on the left, the other half is on the right-hand side. Very good. So what is my second step? Step 2. Let me find the standardized test statistic. Which is Z equals to, well, let us follow the formula. P1 hat minus P2 hat minus P1 minus P2, which is 0, divided by, well, the standard error is square root of P bar, remember that, P bar is x1 plus x2 divided by n1 plus n2 times 1 minus P bar, 1 minus this fraction, x1 plus x2 divided by n1 plus n2 times 1 over n1 plus 1 over n2. Very good. So now we need to find each piece of information and then plug those in and see what do we have. Very good. Let's take a look at the question, see what information also are given to us here. So you have, in the first one, you have 150 randomly selected, and in the second sample, you have 200 of them. Well, so what do we have? We have 74% for the second sample and 86% for the first sample. I need to find x1 and x2. Take a look at this. This is your sample one. In sample one, P1 is equal to what percent? Well, 86%. But what's the definition of P1 for sample one? Let's put a hat on top of it. It is defined as x1 over n1. So 86% is equal to x1 divided by n1. N1 is the first sample size, which is 150. Well, if you solve for x, x1 is 86% times 150, which is equal to 129. So x1 is 129. This is your x1. With the same process, you can find your x2 as well. For the second sample, sample 2, P2 bar is equal to 74%, 74%, or 0.74, which is defined as x2 over n2. So 0.74 is equal to x2, but n2 is given to us. N2 is 200. So x2 is 200 times 0.74. So x2 is equal to 148. Very good. So we have these missing information. Now we can just plug them into this formula and then calculate our z value. When we have the z, we can easily find the p value and compare it with alpha, which is 10%. Very good. Let me move this board a little bit here so we can write for z. Z is equal to P1 hat. Well, we know P1 hat is 86%. We already have it, 86%. Minus P2 hat, which is 74%. Now for the denominator. Here you have the square root of x1 plus x2, 129 plus 148 divided by n1, which is 150 plus 200 times 1 minus this fraction, 129 plus 148 divided by 150 plus 200, close the parenthesis, and the last one is 1 over n1, 1 over 150 plus 1 over 200. Okay, very good. So z is approximately 2.73. I have my z. I have my z, which is here. This is my z. Now that I have my z, I can find this little area and multiply it by 2 to get the whole area, because it is a half p-value, and this is a half p-value. Okay, let's take a look at our calculator. Let's turn on the calculator. Okay. Second bars, normal CDF. Your lower limit is 2.73, 2.73. Your upper limit is, for example, 10, and your mean is 0, standard deviation is 1. So if you paste it, you get half of the area, which is 0.003. This is 0.003. If you multiply it by 2, you get the p-value. So p-value, this is step 3. Our p-value is 0.006. So obviously p-value is less than equal to alpha, which is 10%. Since p-value is less than alpha, we reject the null hypothesis. So it means that we reject the claim. So we reject the claim, because claim and the null are the same thing. Let's check our calculator to make sure our calculations, they are all correct. So we go to stat and we go to tests. Now we're going to use two proportion z test. So we're going to select two proportion z test. Let's write it down. Use your calculator. Here. Calculator. Stat. And tests to proportion z test. Okay, let's go to our calculator and check to see if our calculation is correct or not. Very good. So what is x1? We calculated everything here. We're just going to enter them. X1 is 129. What is n1? N1 is 150. What is x2? X2 is 148. N2 is 200. And as you know, we have a two-tailed graph. So that's why we select P1 is not equal to P2. Let's do the calculation. Well, let's see what do we have. It says, hey, your Z should be 2.73. And let's go down a little bit. And here you have N1, N2, P bar. Do we have information on P bar? Nope. Okay, that's fine. And P value is 0.006. Our P value is the same here. And our calculations, they are all correct. The smiley face here. And that's how it's done.